Okay, so let's go through the part B, right? So we are asked to prove that the maximum possible volume of the cylinder is given to be 4 pi h cubed over 81. So this one obviously is a maxima minima problem. So with this one, we also learned in back in the days of AMAS. Okay, for the first part, I believe you are able to show d equal to h minus r squared root 3. So means I must make use of the result, right? Okay, so with this, right, of course, maximum volume, every time you see maximum volume, you think of the derivative to be equal to 0, meaning dv dr is equal to 0. So you might be wondering, hey, how come it's not h dv dh equal to 0? Because apparently, right, they say that h is fixed. Means that it's not a variable. So we cannot say, oh, dv dh equal to 0. So you must say dv dr is equal to 0. Okay, so with this out of the way, let's do the calculation. For example, right, volume is equal to pi r square height. So of course the height, right, I put like that. I use the h minus r square root 3, then put a square bracket. So you do the expansion first before you do any differentiation. So pi r square height minus pi r cube square root 3. Okay, with this, right, it's time to differentiate. So dv dr, because h is a fixed constant, so I just differentiate respect to r. So you do the first term here, right? So first term you differentiate v with respect to r, so means you will get 2 pi r h. Okay, so the second term is here, so you differentiate this with respect to r, means you'll get 3 pi r square root 3. So this will be dv dr. So since I know it's maximum, right, so you just equate to 0. So with this, you can actually put like that. So you can do some cancellation of the term. So 2 pi rh equal to 3 pi r square root 3. Or maybe I just put the square root 3 in front. So 3 square root 3 pi r square. Okay, so you can cancel the pi, you can cancel the r as well. So what is left is 2h equal to 3 square root 3 r. So maybe I can make r the subject. So I make r the subject, right? R is equal to 2h over 3 square root 3. Okay, so after I get r in terms of h, right, I can actually go back to the volume thingy. So for example, right, they say they want the maximum, for us to show the maximum possible volume, right, to be 4 pi h cubed over 81. So back to the volume equation, or volume formula, right, pi r square, then you times the height, h minus r square root 3 square bracket. So apparently you can see that the form that they want, right, is fully in terms of h, means that I cannot have any r. So that's where I need to go back to this part, right? So that's why I actually make r the subject, because I want to replace all the r with our h. So okay, maybe I write the equation here. So v is equal to pi r square height, right? So height is the h minus r square root 3 square bracket. Okay, so I replace pi r square, pi. Okay, r square, I just put 2h 3 square root 3 and put a square. Then this one, h minus r square root 3. Right? So 2h 3 square root 3. Of course, this thing is right. Is this thing. So square root 3 right here. So this part is this thing. Okay, so before you do any expansion, you do the manipulation first. Meaning you just do the thing, the bracket first, right? So this whole thing right here is 4h square over 9 3 bracket. So same thing inside the square bracket, h minus, so this thing can cancel already, right? So for the square root 3 here and the square root 3 is cancelled, so it means you'll get 2h over 3, then put a square bracket. Okay, as such, you can do your expansion already. So 4 pi h square over 27, h minus 2h over 3 square bracket, expand inside. So this will give you, okay, the first rainbow, right, is 4 pi h cubed over 27. Second rainbow, 8 pi h cubed over 81. Okay, then after that, you just do the calculation. So you do the calculation, right, you'll realize that because you look at this one is the 81, this one is the 27. So means for the first fraction, you need to times 3 here, you need to times 3 here. So this will give you 12 pi h cubed over 81 minus 8 pi h cubed over 81. So in turn, right, you will actually get 4 pi h cubed over 81. So in this, you show that you actually prove the thing already. But there's actually one more thing to get the full credit, because they say it's a maximum possible volume. Means you need to prove to them that is actually maximum. Okay, so how do I prove that is maximum? Very simple. We simply just use the second derivative test lah. So for example, I go back to the thing first. Where is it? Okay, I saw the thing. Okay, so you see this one. So this is your dvd. So I need to do my second derivative, d square v over dr square. So of course, this one is 2 pi h minus 6 pi, because this thing bring down, right? So 2 bring down become 3 times 2, 6, right? 6 pi r square root 3. So this thing, so of course I must sub the r to be as such, right? 2 pi h minus 6, okay, I'll just put the square root 3 in front, pi, okay, r, so this r, just put whatever you see here. So this will be 2h over 3 square root 3, put a bracket. Okay, so just do a manipulation. 2 pi h minus, okay, so this thing can cancel, right? So what is left is the 12, okay, so 12 pi h, 1, 2, 4, okay, divide by 3. Okay, so after that you can actually do the thing, right? So for example, 2 pi h minus this thing is actually just 4, because 12 divided by 3 is 4, right? 4 pi h. So 2 pi h minus 4 pi h, you will get actually negative 2 pi h. And I can say that this is a negative number. This whole thing is a negative. Why is that so? Because pi is 3.142. H is the height of the cone, right? So height of the cone will definitely be a positive number, right? So this whole thing will be less than 0. And always remember, right, more is less, less is more. Hence, this is a maximum volume. Yeah, so that's how we actually do question 2b.